Hi class, it's Mr. V. Today is day 14 of the Algebra 2 Honors Summer School out of 16 days. This is our last day to be discussing polynomials. I have a few practice problems for us to go through. Looking at this first one, identify the number of solutions. And use my pen here. The number of solutions is the same as the degree of the polynomial. This is a fourth degree, so there are going to be 4 solutions. This is a 6th degree polynomial. There will be 6 solutions. I'm not telling you whether they're going to be real or imaginary, if they're going to be positive real roots or negative real roots. I'm just telling you the number of solutions. Find all of the zeros of the polynomial function. One way to do this is to graph it on, and I would use Desmos. So if I graph the first equation on Desmos, it looks like this. When I click on the graph itself, it highlights these points, and I'll click on them to have them come up, and they tell me what the roots are. The roots are -5, -2, and 2. I could also do this by guessing and checking, and by going, let's see, the coefficients of this are 1, 5, -4, and -20. And I could select one of those values that I think is the root, say 2. If 2 is one of the solutions, I could do synthetic division. Bring down my 1. 2 times 1 is 2. This is 7. 7 times 2 is 14. 14 minus 4 is 10. And 10 times 2 is 20. And this is 0. It has a 0 remainder, which means that this is a factor. 2 is a factor. Or, I'm sorry, 2 is a solution, so x minus 2 is a factor. And it wants to find the zeros, so the 0 is 2. If I have this leaves me with a remainder, the 1x squared plus 7x plus 10 with remainder 0. And this one I can factor. And I can factor it by going two numbers and multiply to give me 10 and add to give me 7. And I don't know what those are. So I would use the quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And when I plug in those numbers, I have -7 plus or minus the square root of b squared, which is 49, minus 4 times a times c, which is minus 40, all over 2 times 1. So this is equal to -7 plus or minus the square root of 9 is 3 divided by 2. Or -7 minus 3 divided by 2 is a -5. And my answer could also be -7 plus 3, which is -4. So it could be -2. And that's what I said before. The roots are -5, 2, and -2. And there you have it. You would do the second equation the same way. I may do it in class. Given the degree and the graph, determine the number of imaginary zeros. Well, we know this is a 4th degree polynomial. We know that it is going to be starting with a positive value because its end behavior is positive. And because it's 4th degree, its starting behavior, it's even. So this is going to be a positive as well. You can see that it crosses the x-axis in 2 places. And so it's going to have 4 roots, and 2 of them will be real. That means that 2 of them will be imaginary. You can't have one imaginary root and have all positive coefficients in your polynomial. Here the end behavior is positive, so we know that the highest degree of term is going to be positive, and a positive coefficient. It has a negative beginning, which makes this, of course, this is a cubic, we're told that, and it crosses the x-axis 3 times. Since it crosses the x-axis, those are real roots. Imaginary roots would be 0. Write a polynomial function of f degree that has the rational coefficients of leading coefficient of 1. I'll do the second one for you. I've done another one like this first one in yesterday's lecture. So if 4 is one of my roots and negative square root of 5 is one of my roots, That means that the factors would be x minus 4. That would be one of them. And then one of the factors would be x plus the square root of 5. Now, if I use the square root of 5, that's irrational. So I need to use the conjugate of this as well. So I would also have x minus the square root of 5. And these are my three factors. When I multiply them all together, I will get a polynomial function of the least degree, because I've got the three factors, that has rational coefficients. That means the numbers next to the terms are all rational. Let's start by doing this first one. You have x plus the square root of 5 times x minus the square root of 5. And when I multiply this together, I get x squared, a positive square root of 5x, a negative square root of 5x. Those two cancel. And a negative square root of 5 times positive square root of 5 is negative 5. So this is the same as x squared minus 5. When I multiply it by the last term of that I said is going to be one of the factors, x minus 4, I'll get x cubed minus 5x minus 4x squared plus 20. So my polynomial, this piece, becomes x cubed. The leading coefficient is 1, just like we were told up here, minus 4x squared. Notice I'll put these in order of largest degree to smallest, minus 5x plus 20. And there you have it. We may do this one in class. Determine the possible number of negative real zeros and imaginary zeros for each function. Let's see. Let's do this one just for grins. If x is positive, then the first term would be positive. The second term would be positive. The third term would be negative. The fourth term would be negative. The fifth term would be positive, and the sixth term would be negative. So this is going to turn 3 times. You'll have 3 positive real roots, or you'll have 1 positive real root. If the x term is negative, then our first term would be negative. Our second term would be positive. The third term would be positive because you'd have a negative cubed times with a negative sign in front of it. The fourth term would be negative. The fifth term would be negative. And the sixth term would be negative. So you're going to have 2 negative real roots, possibly. And if we look at this, it's a 5th degree polynomial. That means that there have to be 5 roots. So 3 could be positive and 2 negative. 3 could be positive and 2 imaginary. I don't know until I do this, which ones they are. I could have 1 positive, 2 negative, 2 maximums negative that I could have. I could have 2 negative and 2 imaginary. That adds up to 5. These all have to add up to 5 because there are going to be 5 roots. Some are imaginary, some are not. Or I could have 1 and 0 and 4. Use synthetic substitution and find f of 2 and f of negative 1. Finding f of 2 of this first one. My coefficients are 1. The coefficient of x cubed is 0. Coefficient of x squared is 2. The coefficient of x is 0. And my constant is negative 9. When I divide this by 2, being one of my solutions, I'll say 1. 1 times 2 is 2. So I have 2 left over. 2 times 2 is 4. 4, and this makes this 6. 2 times 6 is 12. 12 left over. 12 times 2 is 24, and 24 plus 9 is 15. So my remainder is 15. This means that f of 2 is equal to 15. I'll do the second one just for grins. I'll do it a different color. Maybe we can see it differently. If you're unable to see this, I'm sorry. I'm trying to get the type as big as I can. First coefficient, which is a term of the 5th degree, here, 5th degree, is 1. X to the 4th is 0. X cubed is a negative 7. X squared is 0. Negative 4 is the one for x, and then a 10 is my constant. And if I were to divide this by, let's use the negative 1 here, negative 1, I get bring down my 1. 1 times negative 1 is negative 1. Here we have negative 1. Negative 1 times negative 1 is 1. This would be negative 6. Positive 6. Then we have 6 times negative 1 is negative 6. And we have negative 10. And negative 1 times this is 10. So my remainder is 20. This means that f of negative 1 for the second equation, which is the one I'm doing for the first equation. Did I do this right? For the first equation. This is for the second equation. This one would be for the first equation. For the second equation, the f of negative 1 is 20 for equation number 2. Find all the zeros of a function. Well, the zeros are the values that are going to make this equation true. Some of them may be real. Some of them may not be real. I'm going to use GeoGebra. This is x to the fourth minus 3x minus 5x to the... So I think I've plotted this before. X to the fourth. Here we go. Here's the function. And it says the zeros are going to be negative 1, positive 1, and 4. So I could write those down from the graph. I'm going to say x is equal to negative 1, positive 1, and 4. And that's the only times that this crosses or touches the x-axis. But wait a minute. This is a fourth degree polynomial. Where's my fourth root? You need 4 roots. And this is where I show this one here. We have a double root. At negative 1, it's a turning point. So it goes up, and at this point, it goes down and then up. Again, this means that this is a double root. So it's actually negative 1, 4, and 1 and 4. And since this is the same, I just leave it like this. But this is a double root. That's why it has 4 roots. Here we have an equation. Find all the rational functions of each rational function. So this is the only ones that I want are the ones that are showing up on the graph. And if I do this on my grid, I have here on the grid, I have negative 4, 0, negative 1, 0, and 1.5, 0. Negative 1, negative 4, 0, negative 1, 0, and 1.5. These are not factors. These are the solutions, or the zeros. So if I were to write the factors, which it did not ask for, but it could ask for, don't get confused. This would be x plus 4 is equal to 0. X plus 1 is equal to 0. Or x minus 1.5. And when you multiply those out, if those are equal to 0, this is where it crosses the y-axis at 0. So this would be these are my solutions, or rational zeros. And that's all that we have for today. Good luck and success.